Hi and welcome to Geeks for Geeks. Today we would be solving the problem city with the smallest number of neighbors at a threshold distance. So the problem statement is self-explanatory, but still we just need to know the definition of neighbors here. What do you mean by neighbors at this point? So here in this problem you are given an undirected weighted graph. This is the very first thing that is important. What you are given is undirected weighted graph itself. This is you are given. Now what you are asked, let's say the undirected weighted graph is something like this, and this is the first sample test case. We would see to it, but let us just see more. Undirected weighted graph. What you are asked, the number. So you are given an undirected weighted graph and you are asked to find out the node which has the minimum number of neighboring nodes. Seems a little bit difficult. I understand. So here, let's say you have a society at this point, okay? Let's say we have a very big society, and in that society, there are different set of towers that are there, okay? And there exists some different set of roads too, okay? Like if I just draw this, and each road, to travel each road we have an associating cost to it. These are the towers in a particular society. We have a cost associated with each path, that if we travel that path we would have a cost like this. So let's say this is tower, this is the tower 2, this is the tower 3, tower 1 and tower 0, and these are the different paths we have and these are the cost associated. Okay, this is the map of a society. Now what is the problem is asking is the tower which is the most expensive tower, most expensive tower. What do I mean by that? Let's say I have a budget, okay? I have a budget, and let's say for this question, the budget is 4 rupees. Now I want to know that if I have 4 rupees, which is the tower which is the most expensive, in what terms? Like if I live at tower 3 and I spend 4 rupees to visit, and I have a budget of spending 4 rupees to visit each tower, how many towers I can visit? So let's say this is to reach tower 2 from 3. I can visit tower 2 with a cost of 1. So I would say I can visit tower 2 with a cost of 1, which is less than the budget, so I would just write it. I can visit 1 with the cost of 4, but there is a better alternative to this, that is the cost of 2. So from 3 I can visit 1 with a cost of 2 by taking this path. So now 2 and 1 is done. Now can I visit 0? So by no means I can visit 0. Why? Because even if I take this path and then I take this path, then 3 plus 1 plus 1, which is the cheapest to reach 0, is 5, which is greater than our budget. So I can say that if I live at 3 and I have a budget in mind that I would spend at max 4 rupees to visit all the other towers, then I can only visit from 3, I can only visit 2 and 1. अर्थात हिंदी में समझा जाए तो अगर मेरे दिमाग में एक बजट है कि मुझे जानना है कि मेरे दोस्त अलग अलग टावर्स में रहते हैं और मुझे जानना है कि मेरे दिमाग में एक बजट है और मैं इतना ही स्पेंड करूंगा एट मैक्स, तो मुझे जानना है कि टावर 3 से मैं कितने टावर्स जा सकता हूं उस बजट को रिस्पेक्ट करते हुए. Okay, the problem is asking this. So let's do the same thing from tower 1 now. From tower 1, if I visit tower 0, the budget would be respected with a cost of 3. So I would write for 1, I can move forward to 0 and I can respect the budget. I can move forward to 2 with a cost of 1. So the budget is also respected. Okay. Now I can visit to 3 also with a cost of 4, which is within my budget. Okay, we're just touching my budget with a cost of 4, and I can also take this, which is cost of 2, which is better. So I would say I can visit all the other cities from 1, respecting the budget. If I do the same thing for 2 now, so from 2, if I visit 0, the cost would be 4. So good enough. From 2 I can visit 0. From 2 can I visit 1? Yes, by using this with a cost of 1. From 2 can I visit 3? Yes, I can do that. So 3, 1 and 2 is done. The remaining one is 0. So now let's see for 0. From 0 can I visit 1? Yes, with a cost of 3. So from 0 we can visit 1 with a cost of 3. From 0 can I visit 2? Yes, with a cost of 4 again, which is within our budget. So I would say 2 also. Okay. Now, from 0, can I visit 3? So if I take the shortest path to visit 3, the cost would even be more than my budget. So I can't really visit 3. From 4, 1, 2 and 3. Yes. So now there are, so if you see, from 1 I can visit 3 cities, from 2 I can visit 3 cities, from 2 I can visit 2 cities, and from 3 also I can visit 2 cities. Here this one would be 3. So now if I look at the most expensive tower, what is the most expensive tower? The most expensive tower would be the tower from where we can visit the minimum number of towers. But there exist 2 like this. What are the different ones? Here we have 3 where we can visit only 2 towers. Here we have 0 where we can visit only 2 towers. So the candidates we have for the node which has minimum number of neighbors at 0 and 3 both have the same value. Now in this question you are told that if there are multiple answers to a particular value, then we would take the node with the greater value. That is why the answer to this is 3. Okay. So here in this question you meant that neighbors just mean not direct neighbors. Neighbors are all the other nodes that we can visit from that particular node. And the node which has the minimum number of neighbors, they would, respecting the budget, would be eligible for the answer. Now if there are multiple answers with the eligibility, then we take the maximum value of the label of the node, that is 3. Okay. So if you observe from each node, what we really need to do is we need to find the shortest path to all node. Okay. So if you observe, what are we really doing? From each node, find shortest path to everyone, and all the folks and all the other nodes and all the other values, like from a particular from a particular 3, if I calculate the shortest values to everyone, for 3, the shortest value from, if I take hold of 3, the shortest path to 2 is 1. The shortest path to 1 is 1 plus 1, this path. Okay, if I take up this path, the distance would be 2 to reach 1, and this one would be 1 plus 1 plus 3, that is 5. Now, all the values which are less than our budget would be considered as an answer, or we would increment the count. Okay, so for each node we would find the shortest path to everyone. Okay, and in the resulting phase, all the nodes whose with cost less than equal to the budget less than equal to the given budget would be, like for 3, if I have 4 nodes, if for 3 I have 2 nodes, whose cost is less than the budget, so the value would be incremented. Increment the value, all the nodes which have this. So for 3 the value would be 2. So we don't really need all the nodes, if you observe, like we just need the count of it. That is why we just can keep the count also. The count is enough, we don't really need to keep the nodes, if you observe. Okay, the count is enough, and we would do this for all the nodes. At the end, we would consider all the values which has the minimum count, and then out of the minimum count we would take the maximum label thing. So if you now, let us see if we can solve using this approach or not. So what is the shortest path? What is the algorithm to find shortest path in a directed graph? The algorithm to find shortest path in a directed graph are 2. That is the Bellman-Ford and Dijkstra. These are the 2 algorithms we have. Now, if you go in the constraints and see, then the values are always positive. Okay, if you observe, the values are positive. And we know that Bellman-Ford works for negative edges too, and Dijkstra works for only positive edge. So if we have all the weight value as positive, then Dijkstra would be the perfect solution for us. Okay, we are observing that we want shortest path in a directed graph and all the weights are positive, so we would use Dijkstra. Now at this point, if you don't really know what is Dijkstra, consider going in the description of the video, learning the algorithm that is already taught by me, then coming back to this video, because I won't be implementing the Dijkstra again. This is not the idea here. Here we want to just comprehend the problem statement, just have the solution from it. It is a predefined algorithm which can be directly implemented in this. We don't have any variation of that algorithm. So a direct implementation of algorithm which is already taught would be skipped in this, to keep the length of the video short and to skip the recurring things. Okay, and to skip the repetitive things. So now we would use Dijkstra to do it. Okay, now to do Dijkstra, here we are given a set of nodes. How we are given? We are given U, V and W. So we would be converting the set of U, V and W to adjacencies. matrix, adjacency list, and then we would be running Dijkstra, and at the end we would be doing this comparison. Now let us see the dry run in practice. Now we would build out the adjacency matrix in the very first statement. So first we would declare this line. After declaring this line, we have something like 0, 1, 2, and 3. Now on this index we would start keeping the values. Okay, so the very first one is u, v, and wt, that is u, v, and wt. So we go to 0, insert 1 with the weight as 3. We go to 1, insert 0 and add the value 3. Why? Because we are given an undirected graph. So if there is an edge from x to y, there is also an edge from y to x, because this is undirected. Okay, so we go to the second one, we go to 1 and insert 2 with the weight as 1, and then we are told that we have something like u, v, and wt. So we would go to 1, insert 2 with the weight as 1. We would go to 2, insert 1 with the weight as 1. And then we have again u, v, and wt. So we would go to 1, insert 3 with the weight as 4. We would go to 3, insert 1 with the weight as 4 itself. Then we would go to 2, insert 3 with the weight as 1. We would go to 3, we would insert 2 with the weight as 1. So this is how the value g would look like after we implement this. Now let us move to the next part of the code. I would break down the code at each point and explain you what I am doing. So this block of code is running Dijkstra for all the nodes. Okay, this part is Dijkstra. This part is Dijkstra, where we insert the source with the distance as 1. Then we insert it to the priority queue, and till the priority queue is empty, we just keep assigning the minimum values out of it. Okay, and we do this for all the nodes. So basically we are running Dijkstra from all the nodes. Now after we have done the Dijkstra for all the values, we would have something we would have the distance matrix. Okay, like we would have let's say a matrix of 1, 3 cross 3. What is the distance to reach from 1 to 2? What is the distance to reach 1 to 3? What is the distance to reach 2 to 1? All those values would be stored at this point. After this is done, what we start doing is, if the distance from I, if the distance to reach j is less than our given budget, we just increase the count. Okay, we are just increasing the count. So what would this look like? This would look something like this, that after 3 the value is just 2, for 1 the value is 3, for 2 the value is 3, for 0 the value is 2. We have something like this, and all the nodes, now we would start comparing the values. So if we have any new node which has less than whatever was previously there, like we started off with 100, we saw that from one tower we can only visit 8 towers. So I would say, okay, this is the new answer. So we initialized it with a very large value. If we see a new value which is less than the previous value, we assign it. if let's say we have something like tower 8 with the neighboring as let's say 2, tower 8 has two neighboring towers, and this is, as of now, this is the best answer. Then we found new tower, that is tower 9, and this has the neighboring as same as 2. So if this kind of situation occurs, then it is told that we would take the maximum value out of those labels. That is why we are keeping the max of it, and then we are returning it. Now I would just sum up all the solution, try to submit it if it works or not, and then we are done. So now let us see if this code would work or not. And yes, we got an AC. That's it for today. Thank you and have a nice day.